This diagram shows 5 mathematical gears that drive our measurable universe: the speed of light, the gravitational constant, Planck's constant, Boltzmann's constant, and the fine structure constant. These exact numbers govern everything from the glow of a star to the arc of a thrown ball. Modern physics assumes these values are locked in place as eternal, hard-coded inputs installed at the very beginning of time. But a closer look at the physics points toward a different possibility. These values might actually be the fossils of a deeper, unseen geometry. If true, the rules of the cosmic game are far more dynamic than we thought. We have to ask if the universe was handed its physics, or if it developed them over time. Welcome to Case 11, the final episode of the GEM Files, and the ultimate conclusion to our journey through the vault of broken physics. We are not here to reject the massive successes of modern science. Our goal is strictly forensic. We are examining stress fractures in the data to see where our current models might be incomplete. The equations of modern physics work brilliantly, but the underlying constants, the monuments we once thought were fixed forever, may actually be signs of an evolving system. Over the previous 10 cases, we examined an array of cosmic mysteries. Instead of treating them as random trivia, we can read them together as a single diagnostic report on the state of physics. This data ledger maps out those stress points, starting with the early universe. We saw how the ancient abundance of lithium refuses to align with our models, and how measurements of Hubble expansion seem to conflict depending on which era of the cosmos we sample. Scaling up to the cosmic level, the raw energy we calculate for the vacuum vastly outweighs the persistent pressure we actually observe, and the mysterious missing mass we call dark matter might actually be an effect of deep cosmic geometry. The ledger continues to fill when we look at local physics. We find anomalies in neutron decay routes, the precise wobble of the muon, the survival of matter over antimatter, the hyper-accelerated formation of early galaxies, and the enormous gap between the strength of gravity and the other forces. Taken individually, each of these is a highly specific headache for physicists. Read together, they pose a massive unifying question. What if these distinct cracks are all symptoms of the exact same missing geometric layer? The standard model treats the constants as fixed numbers, because doing so yields undeniable, extraordinary calculation precision. That success is absolute, and any new theory has to respect it. However, absolute fixity today may actually be a sign of an extremely mature state of local stabilization. In this light, constants appear to be the specific rules that our universe has successfully stabilized, rather than parameters given to it from the outside. This brings us to the framework of general emergence mechanics, or GEM. This approach suggests that the universe actively learns which physical structures it can successfully hold over time. This line graph plots time on the horizontal axis against a property called persistence depth on the vertical axis. The math here describes depth monotonicity, a curve showing that as the universe evolves, its effective persistence depth strictly increases. Notice how the early universe occupies a highly variable zone with lower persistence depth. Over time, that volatility smooths out into a stable, mature flatline. This depth evolution implies the early universe functioned under an entirely different effective parameter regime than the one we measure in the modern cosmos. The constants appear perfectly fixed to our instruments today, strictly because we exist inside a mature, deeply stabilized interval of this cosmic ledger. The implication here is that the universe does not require arbitrary numbers to function. It specifically requires holdable ones, values that permit coherent persistence. This does not mean the constants drift randomly. Any erratic variation would break persistence and destroy structure. To allow for chemistry, stars, and life, these values must be immensely locally stable. We know they are stable. Atomic clocks and high-precision spectral measurements heavily constrain any present-day variation. A serious scientific approach must acknowledge how effectively this variation is suppressed in the modern era. But the grand GEM hypothesis remains physically testable. We can search for signatures of this parameter stress in the early cosmos, or conduct phase sweep and hysteresis tests in modern laboratories to detect microscopic remnants of that evolution. The vault does not ask for blind belief in a new theory. It simply asks the scientific community to identify where the constants should stop pretending to be eternal. If the constants truly are eternal inputs, then every anomaly, every tension, and every crack we have explored must be painstakingly solved as a separate, isolated problem. But if the constants are stabilized persistence coordinates, the entire picture shifts. The fractures finally make sense as interconnected parts of a single learning ledger. These foundational numbers act as the live coordinates of a universe that is still learning how to remain coherent, behaving more like an evolving memory than a static machine. Are the fundamental constants really constant? Or are they the stabilized memory of a universe still becoming itself?